ഇന്നത്തെ വീഡിയോയിലേക്ക് എല്ലാവർക്കും സ്വാഗതം. ഇന്ന് കേരള PSC ജൂലൈയിൽ നടത്തുന്ന അസിസ്റ്റന്റ് എഞ്ചിനീയർ ഇലക്ട്രോണിക്സ് പരീക്ഷയുടെ സിലബസിനെ കുറിച്ചുള്ള വീഡിയോയാണ് ചെയ്യുന്നത്. ചാനൽ ആദ്യമായി കാണുന്നവരാണെങ്കിൽ ചാനൽ മറക്കാതെ സബ്സ്ക്രൈബ് ചെയ്യുക. വീഡിയോ ഇഷ്ടപ്പെട്ടാൽ ലൈക്ക് ചെയ്യുക. വീഡിയോ കൂടുതൽ പേരിലേക്ക് എത്തിക്കാനായി ഷെയർ ചെയ്യുക. നിങ്ങളുടെ വിലപ്പെട്ട നിർദ്ദേശങ്ങൾ കമന്റ് ബോക്സിൽ രേഖപ്പെടുത്തുക. Syllabus for selection to the post of Assistant Engineer Electronics in Public Works Department. Category number 71/2024. Total mark 100. Module 1 10 marks. Electronics devices. Evolution of electronics. Vacuum tubes to nano electronics. Resistors, capacitors and inductors. Constructional features not required. Types, specification, standard values, color coding, PN junction diode, principle of operation, VI characteristics, principle of avalanche breakdown, Zener diode, photodiode, light emitting diodes, LED, bipolar junction transistors, PNP and NPN structures, principle of operation, relation between current gains in CA, CB and CC, input and output characteristics of common emitter configuration, MOSFET structure, enhancement and depletion types, principle of operation and characteristics, power electronic devices, silicon controlled rectifier, SCR, triac, working characteristics. Module 2 10 marks. Analog circuits, RC differentiating and integrating circuits, diode clipping circuits, diode clamping circuits, transistor biasing, operating point, DC load line, bias stabilization, BJT amplifiers, RC coupled amplifier, design, AC load lines, voltage gain and frequency response, small signal analysis of CE, configuration using small signal hybrid, pi model for mid frequency and low frequency, high frequency equivalent circuits of BJT, Miller effect, analysis of high frequency response of CE amplifier, MOSFET amplifiers, MOSFET circuits at DC, MOSFET SN amplifier, biasing of discrete MOSFET amplifier, small signal equivalent circuit, multi-stage amplifiers, effect of cascading on gain and bandwidth, cascade amplifier, feedback amplifiers, effect of positive and negative feedback on gain, frequency response and distortion. The four basic feedback topologies, analysis of discrete BJT circuits in voltage series and voltage shunt feedback topologies, oscillators, classification, criterion for oscillation, band bridge oscillator, Hartley and crystal oscillator, power amplifiers, classification, transformer coupled class A power amplifier, push-pull class B and class AB power amplifiers, complementary symmetry class B and class AB power amplifiers, efficiency and distortion, operational amplifiers, op-amps, the 741 op-amp, differential amplifiers using BJT, DC analysis, transfer characteristics, AC analysis, differential and common mode gains, CMRR, input and output resistance, voltage gain, op-amp with negative feedback, op-amp circuits with voltage series and voltage shunt feedback, current series and current shunt negative feedback, virtual ground concept, closed loop gain, input resistance and output resistance of inverting and non-inverting amplifiers, op-amp amplifications, summer voltage follower, loading effects, differential and instrumentation amplifiers, voltage to current and current to voltage converters, integrators, differentiators, precision rectifiers, comparators, smithed gates, log and anti-log amplifiers, op-amp oscillators and multivibrators, phase shift and band bridge oscillators, triangular and sawtooth waveform generators, unstable and monostable multivibrator, active filter, comparison with passive filters, first and second order low pass, high pass and band reject, active filters, state variable filters, timer and VCO, timer IC 555, functional diagram, unstable and monostable operations, basic concepts of voltage controlled oscillator and application of VCO, ICLM 566, phase locked loop operation, closed loop analysis, lock and capture range, basic building blocks, PLL IC 565, applications of PLL, module 3, 10 marks, digital circuits, binary and hexadecimal number systems, methods of base conversion, binary and hexadecimal arithmetic, representation of signed numbers, fixed and floating point numbers, binary coded decimal codes, gray codes, access3 code, alphanumeric codes, ASCII, basics of Verilog, basic language elements, identifiers, data objects, scalar data types, operators, Boolean, postulates and fundamental gates, Boolean, postulates and laws, logic functions and gates, De Morgan's theorem, principle of duality, minimization of Boolean expressions, sum of products, SOP, products of sums, POS, canonical forms, Karnaugh map, minimization, modeling in Verilog, implementation of gates with simple Verilog codes, combinatorial and arithmetic circuits, combinatorial logic system, comparators, multiplexers, demultiplexers, encoder, decoder, half and full arrays, subtractors, serial and parallel arrays, BCD arrays, modeling and simulation of combinatorial circuits with Verilog, codes at the gate level, sequential logical circuits, building blocks like SR, JK and master slave, JK FF, edge triggered FF, conversion of flip-flops, excitation table, characteristics equation, implementation with Verilog codes, ripple and synchronous counters, and implementation in Verilog, shift registers, SIPO, SISO, PISO, PIPO, shift registers with parallel load shift ring counter and Johnson's counter, asynchronous and synchronous counter design, modern counter, logic families and its characteristics, TTL, ECL, CMOS, electrical characteristics of logic gates, logic levels and noise margins, fan-out, propagation delay, transition time, power consumption and power delay product, TTL inverter, circuit description and operation, CMOS inverter, circuit description and operation, structure and operations of TTL and CMOS gate, NAND in TTL and CMOS, NAND and NOR in CMOS, Module 4, 10 marks, microprocessors, algorithms for binary multiplication and division, fixed and floating point number representation, functional units of a computer, non-Newman and Harvard computer architectures, CISC and RISC architecture, processor architecture, general internal architecture, address bus, data bus, control bus, register set, status register, accumulator, program counter, stack pointer, general purpose registers, processor operation, instruction cycle, instruction fetch, instruction decode, instruction execute, timing response, instruction sequencing and execution, basic concepts, data path, architecture of microprocessors and embedded processors, architecture block diagram, registers, internal memory, timers, port structures, interrupts, assembly language programming, addressing mode, instruction set programming and interfacing, simple programming, examples in assembly language, interfacing using assembly language programming, LED, 7-segment LED display, programming in C, declaring variables, simple examples, delay generation, code programming, code conversion, interfacing of LCD display, keyboard, stepper motor, DAC and ADC with microprocessors and its programming, advanced concepts, timers, counters, mode and application, serial data transfer, SFRs of serial port working, programming to transfer data serially, introduction to ARM, the memory system, types of memory, RAM, ROM, memory characteristics and hierarchy, cache memory, the basics of caches, mapping techniques, improving cache performance, virtual memory, overlay, memory management, address translation, input or output organization, introduction, synchronous versus asynchronous input-output, programmed input-output, interrupt, driven input-output, direct memory access, module 5, 10 marks, introduction to continuous time signals, definition of signal, basic continuous time signal, frequency and angular frequency of continuous time signals, basic operation on signals, classification of continuous time signals, periodic and non-periodic signals, even and odd signals, energy and power signals, noise and vibration signals, discrete time signals, basic discrete time signals, frequency and angular frequency of discrete time signals, classification of discrete time signals, periodic and non-periodic signals, even and odd signals, energy and power signals, symptoms, system definition, continuous time and discrete time systems, properties, linearity, time invariance, causality, and invertibility, stability, representation of systems using impulse response, linear time invariant systems, LTI system definition, response of a continuous time LTI system and convolutional integral properties, response of a discrete time LTI system and the convolutional sum properties, correlation of discrete time signals, frequency analysis of signals, concept of frequency in continuous time and discrete time signals, Fourier transform of continuous time and discrete time signals, Parseval's theorem, interpretation of spectra, the sampling theorem, signal processing fundamentals, discrete time and digital signals, Basic elements of digital processing system, ADC, DAC and Nyquist rate, frequency, aliasing due to sampling, need for anti-aliasing filters, discrete time Fourier transforms properties, computation of spectrum. Module 6 10 mark. Electromagnetism. Introduction to coordinate systems, rectangular, cylindrical and spherical coordinate systems, coordinate transformation, gradient of a scalar field, divergence of a vector field and curl of a vector field, their physical interpretation, divergence theorem, Stokes theorem, Coulomb's law, electric field intensity, field due to a land charge, surface charge distribution, electric flux and flux density, Gauss's law and its application to determine the field due to an infinite line charge, infinite sheet charge, electric potential, potential gradient, conservative property of electric field, equipotential surfaces, electric dipole capacitance, capacitance of coaxial cable, two-wire line, Poisson's and Laplace's equation, Biot-Savart's law, magnetic field intensity due to finite and infinite wire carrying current, magnetic field intensity on the axis of circular and rectangular loop carrying current, magnetic flux density, magnetic vector potential, Ampere's circuital law and symbol application, inductance and mutual inductance, boundary condition for electric fields and magnetic fields, conduction current and displacement, current densities, continuity equation for current, Maxwell's equation in differential and integral form from modified form of Ampere's circuital law, Faraday's law and Gauss's law, wave equations from Maxwell's equations, uniform plane waves, wave equations in phasor form, propagation of uniform plane waves in free spaces, lossless and lossy dielectric medium, uniform plane waves in good conductor, skin effect and skin depth, phase velocity and group velocity, intrinsic impedance, attenuation constant and propagation of uniform plane waves in free space, lossless and lossy dielectric medium, uniform plane waves in good conductor, skin effect and skin depth, phase velocity and group velocity, intrinsic impedance, attenuation constant and propagation constant in all medium, Poynting vector and Poynting theorem, transmission line, waves in transmission line equation and solutions, propagation constants, characteristics impedance, wavelength, velocity of propagation, standing wave ratio, impedance matching, solution of problems, electromagnetic interference. Module 7, 10 marks, basic communication system, analog, digital, TV, CCTV, examples of analog communication systems, frequency bands, need for modulation, noise in communication system, definition of thermal noise, white noise, various types of noise, short noise, partition noise, flicker noise, burst noise, no analysis required, signal to noise ratio, noise factor, noise temperature, narrowband noise, amplitude modulation, AM, double sideband suppressed carrier, DSBSC, modulation, single sideband modulation, SSB, spectrum, power efficiency of all the three variants, study of only tone, modulation in DSB, SC, AM and SSB, amplitude modulator implementations, switching modulator, balance modulator, AM demodulators, coherent demodulator, envelope detector, frequency modulation, modulation index, frequency deviation, average power, spectrum of tone modulated FM, heuristics for bandwidth of FM, narrowband FM and wideband FM, FM generation, director diode modulator, Armstrong's method, FM demodulation, slope detection, PLL demodulator, Module 5 Super Heterodyne Receiver, Principle of Carrier Synchronization using PLL, NTSC Television Broadcasting, CCTV, Elements of Digital Communication System, Sources, Channels and Receivers, Classification of Communication Channels, Discrete Sources, Source Coding Techniques, Waveform Coding Method, Sampling Theorem, Sampling and Reconstruction, Pulse Code Modulation, Sampling, Quantization and Encoding, Different Quantizers, low and mu-low quantization, Practical 15 level mu and low encoding, Nonlinear source coding, Differential PCM, Adaptive PCM, Delta modulator and adaptive delta modulator, issues in delta modulation, slope overload, signaling codes in telephony, signaling codes in digital telephony, T1 signaling system, AMI and Manchester codes, binary and zero substitution, B3 such as code, B6 ZS code, digital modulation schemes, baseband, BPSK system and the signal constellation, BPSK transmitter and receiver, baseband QPSK system and signal constellation, plots of BAR versus SNR, analysis not required, QPSK, transmitter and receiver, quadrature amplitude modulation, channel coding and receivers, transmission through AWGN channel, capacity of an AWGN channel, receivers, correlation and matched filter, receiver, channel coding schemes, repetition code, block codes, cyclic codes. Module 8, 20 marks, sensors, transducers, speaker, microphone, recording, public address system, transducers, definition of transducers, sensors, classification based on transduction principle, measurement, material and technology, analog and digital transducers, active and passive transducers, primary and secondary transducers, static and dynamic characteristics of sensors, loading effects, resolution, linearity, accuracy, resistance transducer, basic principle, potentiometer, resistor, strain gauge, types, thermistors, RTD inductance transducer, basic principle, linear variable differential transformer, LVDT, RVDT types, capacitance transducer, basic principle transducers using change in area of plates, distance between plates, variation of dielectric constants, frequency response, position sensors, digital transducers, encoders, linear, rotary, incremental linear encoder, absolute linear encoder, incremental rotary encoder, absolute rotary encoder, Types forces and torque transducers, providing ring, hydraulic and pneumatic load cell, dynamometer, sound transducers, sound level meter, sound characteristics, microphone, condenser microphone, torque measurement system, pressure transducers, basic principle, different types of manometers, U-tube manometer, bell-type manometers, level transducer, continuous level measurement, discrete level measurement, mass capacitive level gauges, dead weight calibrator, Hall effect transducers, eddy current transducers, velocity sensors, tachogenerators and stroboscope, rotation rate measurement system, magnetostrictive transducers, fiber optic sensors, semiconductor sensors, basics of seismic instrument and accelerometers, flow transducers, Bernoulli's principle and continuity, orifice plate, nozzle plate, Venturi tube, rotameter, anemometer, electromagnetic flow meter, impeller meter and turbid flow meter, acceleration sensors, heading sensors, compass, gyroscope sensor, IMU, GPS, real-time differential GPS, active optical and RF beacons, ultrasonic beacons, reflective beacons, active transducers, thermocouple, piezoelectric transducer, tactile sensor, proximity detection of physical contact or closeness, contact switches, bumpers, inductive proximity, capacitive proximity, range sensors, IR, sonar, laser range finder, optical triangulation 1D, structured light 2D, performance comparison range sensors, motion, speed sensors, speed relative to fixed or moving objects, Doppler radar, vision-based sensors, CCD and CMOS cameras, processing circuits for different types of sensors, elements of public address system, loudspeaker, characteristics, audio signal recording fundamentals, module 9, 10 marks, power system, load curve, load factor, diversity factor, load curve, numerical problems, generation, conventional hydro, thermal, nuclear, renewable energy, solar and wind, design of a rooftop, ground-mounted solar farm, energy storage systems as alternative energy sources, grid storage systems, bulk power grids, smart grids, microgrids, power transmission system, line parameters, resistance, inductance and capacitance, transmission line modeling, classifications, short line, medium line, long line, transmission line as two ports network, parameters, derivation and calculation, power transmission system, calculation of sag and tension insulators, string efficiency, grading corona characteristics of transmission, line surge, impedance loading, series and shunt compensation, underground cables ratings, classification capacitance, grading testing, EHVAC, HVDC and FACS, switchgear, need for protection circuit breaker rating SF6, VCB, principle of GIS, protective relays, electromechanical relay, static microprocessor and numeric types, principles of overcurrent, directional, distance and differential, types of protection schemes, numeric relays, causes of overvoltages, insulation, coordination, power distribution systems, aerial bunched cables, insulated conductors, network standards, earthing transformer location, balancing of loads, methods of power factor, improvement using capacities, per unit quantities, single phase and three phase, symmetrical components, sequence networks, fault calculations, symmetrical and unsymmetrical fault level of installations, limits, contingency ranking, load flow studies, types network, model formulation and admittance, matrix, Gauss-Seidel, Newton-Raphson and fast decoupled method, principle of DC load flow, introduction to distribution flow, power system stability, steady state, dynamic and transient stability, power angle curve, steady state, stability limit, mechanics of angular motion, swing equation, solution of swing equation, point by point method, RK method, equal area criterion application, methods of improving stability limits, phasor measurement units, wide area monitoring system, turbines and speed governance, interior inertia automatic generation control, load frequency control, single area and two area systems, subsynchronous resonance, automatic voltage control, exciter control, SCADA systems, economic operation, distribution of load between units within a plant, transmission loss as a function of plant generation, distribution of load between plants, rectifiers, block diagram, description of a DC power supply, working of a full wave bridge rectifier, capacitor filter, regulated power supplies, Zener voltage regulator, series voltage regulator, DC to DC conversion, circuit block diagram and working of SMPS, voltage regulators, fixed and adjustable voltage regulators, IC 723, low voltage and high voltage configurations, regulated power supplies, shunt voltage regulator, series voltage regulator, short circuit protection and fallback protection, output current boosting, uninterruptible power supplies, UPS, online UPS, offline UPS, line interactive UPS. ഇന്നത്തെ വീഡിയോ ഇവിടെ അവസാനിക്കുന്നു. ഇന്ന് അസിസ്റ്റന്റ് എഞ്ചിനീയർ ഇലക്ട്രോണിക്സ് പരീക്ഷയുടെ സിലബസിനെ കുറിച്ചുള്ള വീഡിയോയാണ് വിശകലനം ചെയ്തത്. ചാനൽ ആദ്യമായി കാണുന്നവരാണെങ്കിൽ ചാനൽ മറക്കാതെ സബ്സ്ക്രൈബ് ചെയ്യുക. വീഡിയോ ഇഷ്ടപ്പെട്ടാൽ ലൈക്ക് ചെയ്യുക. വീഡിയോ കൂടുതൽ പേരിലെത്തിക്കാനായി ഷെയർ ചെയ്യുക. നിങ്ങളുടെ വിലപ്പെട്ട നിർദ്ദേശങ്ങൾ കമന്റ് ബോക്സിൽ രേഖപ്പെടുത്തുക. എല്ലാവർക്കും നന്ദി.